In one of my videos on the DualSense controllers, I said that at a minimum, you will want a 60-watt soldering iron to replace the joystick modules. But does that apply to the no-name soldering irons from Amazon? So I thought I would take a look at the 60-watt plus, very cheap soldering irons. I thought this would be a good test to see if wattage would be a good indicator of a usable soldering iron. I set my price limit at $20, and there were plenty to choose from, and the wattage goes from 60 to 100 watts. At least that is what the ad says. Now, if you are looking for a soldering iron for your workbench, these are not the irons you're looking for. I'm reviewing these from the perspective of needing a soldering iron for a small one-time project. Take the comments I make about these irons from the point of view of the iron gets used once and then goes in a drawer for 6 months. If you're planning to use a soldering iron even once a month, don't buy any of these. Don't do that to yourself. The cheapest iron is the TXINLEI brand. It says it is 60 watts. Comes with the iron, 6 tips, and what is called a stand. At $6.99, I almost didn't buy this one. But I did decide to give it a chance. I did say 60 watts. The next few irons are right at the $10 mark. This one had a few % discount at purchase time, so it ran me $8.99. And can see this one is currently unavailable. There were 4 or 5 different colors of this iron, and the other colors are still available as I'm recording this. This is listed as 68 watts in the ad. The box says 120 watts, so I'll see what is up with that. Kit comes with the iron, 6 tips, some solder flux, solder, a very tiny stand with sponge, and instructions. There are 2 irons of this brand KERNOWO in my test batch. This one has the item number 561D blue. This next one is the LIOUHOUM brand. Ad says 80 watts, and I paid $9.98 for it. Comes with the iron, 6 tips, solder flux, solder, very tiny stand with sponge, and the instructions are on the back of the box. This is the YIHUA brand, model 947-3. Ad says 60 watts, and I paid $9.99 for it. You get the iron, 1 tip, and a small stand with sponge and instructions. This is a Q-MING brand. There are 2 of this brand in my batch of test irons. This one has an item number of 80W-blue. Ad says 80 watts, and I paid $9.99 for it. Can see it's a few cents cheaper as I'm recording this. Kit comes with the iron, 6 tips, solder flux, solder, very tiny stand with sponge, and instructions. This is a SREMTCH brand. Ad says 80 watts, and I paid $11.39 for it. Kit comes with the iron, 6 tips, solder flux, solder, very tiny stand with sponge, and instructions. This is the MEAKEST brand. The ad says 90 watts. I paid $13.99 for it. Kit comes with the iron, 6 tips, solder flux, solder, very tiny stand with sponge, bent nose tweezers, and instructions. This looks damaged out of the box, but it does still work. I don't know if it was assembled bent like this, or did this happen when it was shoved into the box. The box is packed full, but undamaged. Either way, it's not supposed to be bent like that. This is the second Q-MING kit. It has an item number of SIK 100. Ad listed at 100 watts, and I paid $15.99 for it. Kit comes with the iron, solder flux, solder, solder wick, 6 tips, stand with sponge, and instructions. This is the second KERNOWO kit. Unfortunately, there was no item number for this one, and as I record this, it is unavailable. I'm still going to include it in the test as it might come back in stock. Ad listed as 100 watts, and I paid $15.99 for it. Kit includes the iron, solder flux, solder, 6 tips, small stand with sponge, and instructions. Finally, the HANDSKIT brand. Ad listed as 90 watts, and I paid $18.88 for it. Kit comes with the iron, solder, 6 tips, for some reason a cover that screws over the entire heating element and tip, and a very tiny stand with sponge and instructions. Up first is the TXINLEI brand. I'll call this the PCB test. I'm just soldering and removing solder with some solder wick. It struggles with this test. It has trouble applying enough heat to even make good use of the solder wick. It even has trouble melting the solder on a 1/4-inch square pad of 1 ounce copper. Feels more like using a 25-watt soldering iron, to be honest. I'm going to make an attempt at measuring the tip temperatures. I don't think it will be that accurate, but can be used to compare between irons. I have the temperature set to 400 degrees centigrade, so right around 750 degrees Fahrenheit. It's a dial on this iron, so I don't expect it to be very close. And this is the highest reading I got, and that is really quite good. My FX951 set to 750 degrees will read anywhere from 650 to 720 depending on the tip, so this is right in that range. Here's a 1/4-inch wide, 0.01 inch thick, 2-inch long piece of copper. The iron tip will be applied about 3/4 of an inch from the end of the copper strip, where a small piece of solder will be placed. I'll put some flux on it to help with the heat transfer. It is a tough test, but a 60-watt iron should be able to do it. This iron is unable to complete this test. I'll clean off excess solder and let it cool in between tests. All of the tests done on the irons will be at 750 degrees Fahrenheit or 400 degrees centigrade, whichever they are labeled in, except for the power draw test. I'll run them at their maximum for this test. The fluke meter is reading AC milliamps and the KERNOWO is reading AC volts. Now when it's first powered up, it pulled over 600 milliamps. That would be maybe 75 watts or so. But can see as it gets hotter it is pulling quite a bit less. And this is not a temperature controlled iron. I do have a small block of copper to use as a heat load. It really shouldn't have much effect on the power draw of this iron, but I'll check it like all of them. And it doesn't. Pulling less than 230 milliamps, so that is less than 30 watts. I think this explains why this feels like a 25-watt soldering iron. Technically, I guess this does pull 60 watts, at least for a short period of time. I wouldn't call it a 60-watt soldering iron, and I'm going to say no to this one. This is the KERNOWO 561D. It did do better than the previous iron, but it did not do well. I would hate to try and use this to work on any electronic equipment. This was the highest reading I could get with the iron set to 400 degrees centigrade, so I would say the tip is a bit cooler than the previous iron. As for the copper strip test, this one is a fail as well. If it can't keep the solder melted at the iron tip, really no chance of it completing the test. I did give it over a minute to be sure. I do think the output temp from it is low, but even with that, it can't supply enough heat to do any real work. Now for the power test. At power up it pulls over an amp, but it drops fast. Now this is supposed to be a temperature controlled iron. And with no thermal load it's pulling less than 60 watts. I'll put a bit of fresh solder on the tip to make sure I get good thermal contact. Power is not really going up, so at maximum temperature and a heavy thermal load, it is pulling around 50 watts. It doesn't seem like power draw changed depending on thermal load, so I wouldn't call that thermostatic design. I call that adjustable temperature, and that's it. This iron just doesn't seem to be able to transfer its heat to the iron tip. I would expect more from this much wattage. I'm going to say no for this one as well. So this is the Liouhoum brand and listed as 80 watts. And it's doing okay on the PCB test. It's usable. Now this is the highest temperature reading I could get with it set to 400 degrees centigrade, so it's right in the range of what I would expect. I think if I'm reading 670, I would expect the tip temperature to be more than that, and that is really not very far from 750. This iron is applying enough heat to keep the solder melted at the iron tip, so a big improvement from the previous two irons. Since this was keeping the solder under the tip melted, I gave it over 2 minutes to complete the test, but it failed. I didn't give it any more time because it didn't look like it was making any progress. I'll set this to its maximum of 480 degrees centigrade. This is supposed to be an 80 watt temperature controlled iron. Looks like it peaked at about 650 milliamps, so right around the 80 watt mark. And it's dropping to around 250 milliamps with no thermal load, but it should go up as I put the tip to the copper block. But it doesn't seem to. The tip did apply enough heat to melt itself to the solder on the copper bar, so that is something. And maybe the power draw has moved up a bit, hard to say. But with a very high thermal load, the iron is pulling around 30 watts. Again, I would not call this a temperature controlled iron, I would call it an adjustable temperature iron. It pulls 80 watts for a short period of time. I don't feel it supplies even 60 watts of continuous heat to the tip, and that is what I'm looking for. So I'm going to say no for this one as well. This is the YIHUA 947-3 iron, listed as 60 watts. It only came with the one tip, and it's a pretty small tip. And it's not doing too bad on the PCB test. Really, it's doing better than I expected with the small tip. This one might actually be close to 60 watts. Or the heater to tip thermal transfer is better. Hard to keep the thermocouple on the small tip, but temperature reading of over 740 degrees. Dial is set as close to 750 as I can, and a peak reading of 748 degrees. I would say the tip temperature is plenty hot. I'll put a bit of solder paste on the end of the copper strip, and then place a small piece of solder on the paste and mash it down. This is the process for each of these tests. I'll put some solder on the iron tip to make sure I have good thermal contact with the copper strip. Again, this iron is able to keep the solder melted under the tip. I do think it is doing better than the last iron as the flux is boiling. It's been almost 2.5 minutes. I hate to give up on this one. I think it's so close. If this iron had a larger tip, I'm sure it would have already melted the solder. Let me see how close it is. Oh, there it goes. Very close to 3 minutes. Here is the iron with a wide HACO tip on it. It's not really a good fit as I couldn't tighten down the holder very tight, as the end of the heater is bumping on the tip. This is a lot wider tip. Also, the inside diameter of these HACO tips is a bit smaller, so less air gap between the heater and the tip. But maybe a bit unfair. I think the list price for these basic T18 HACO tips is like $10, so same as the price for the entire iron. I'll let it get to temperature. Granite block is not as cool as when I started the previous test, but there's really not that much difference. But I did think this might be an interesting test. A lot more heat transfer with this tip. And there it goes, around 20 seconds. Let's see what kind of power this iron is pulling. So maybe 700 milliamps at power up, and dropping quite a bit. So I don't think this one's going to make 60 watts continuous either. This iron is just an adjustable temperature iron, so heat load shouldn't make much difference. And it doesn't seem to. And I'm right at 30 watts of power. Makes me think that the thermal coupling between the heater and tip for this iron is better than the previous 3 tested. Again, I would not call this a 60 watt soldering iron. It has completed all the tests. Well, 3 minutes for the copper strip test is not really a success. But this is the best one so far. I could see this iron being usable for a very small soldering project. Would I want to use this to change the joystick module in a game controller? No, absolutely not. I'm not going to say a blanket no on this one. I like the way it feels in my hand. The threading on the tip retainer nut feels quite nice. And this iron is doing a better job of getting its 30 watts of heat to the tip. So this is not what I'm looking for, but could be a yes for a very small project. Before I get to the test of this Q-MING 80W blue iron, I did want to note this about this one tip that came with the iron. The inside of it are oxidizing like no tomorrow. Maybe it's just a one-off and I tried one of the other tips and it didn't oxidize. So probably just a bad tip. This iron is doing pretty good on the PCB test. Really did okay. I don't have any complaints with it. I would say a bit better heat transfer than the 947-3 iron, but this does have a wider tip. Well, I would say this iron's tip temperature is well above the 750 degrees it's set at. Maximum reading of 821 degrees, it's a hot iron. Let me see how well it does at transferring the heat. I'm sure the extra high temperature is going to help here. It's moving some heat. There it goes, less than 10 seconds. But with a tip temperature probably over 100 degrees higher than the others, that does give it an advantage in this test. But it still completed the test at the 400 degrees centigrade setting. A little over 700 milliamps at startup. I'll set the temperature to 480 degrees centigrade, the maximum. Now this is not listed as a temperature controlled iron, just adjustable. And power draw has dropped to about the 30 watt range, like all the others. And I'm sure it's making good thermal contact because it's soldered to the copper bar. Current goes up a bit, but still looking right at the 30 watt range, if my power draw measurements are correct. So it's not like this iron has better heat transfer or power output, it just runs the tip temperature a lot hotter. This could be a bit dangerous on a circuit board. If the tip temperature is maybe over 850 degrees, it wouldn't take much to damage a circuit board. I would rather an iron output low than high. The tip temperature bothers me, but could turn the temperature down and this be a usable soldering iron. I'm not sure about the 30 watt continuous power measurement. I'm going to say maybe on this one. This SREMTCH brand iron is doing so-so on the PCB test. Heat transfer is a bit uneven, I would say. It is able to handle the solder wick. Seems plenty hot at first, but cools off very fast. I would note that even with this little use, one side of this tip is getting hard to keep tinned. It should come as no surprise that these tips are quite cheap. Hard to get a good reading. Coating on this tip is just about completely gone. So it probably is running quite a bit more than the 715 degree reading I got. It really doesn't feel that much cooler than the previous iron, so it may be running above 750 degrees. It melts the solder as the tip seems hot. Tip is cooling off though. This thing has a real problem with heat transfer. And I don't think tip coating is the problem with that. It just can't transfer enough heat. It is just barely able to keep the solder melted. And it's losing the battle at that. This one is not going to make it. This pulled a bit over 900 milliamps at power up. Again, this is supposed to be a temperature controlled soldering iron, and power is dropping as it should, down to about 35 watts with no load. But power is not going up when put under a thermal load. Here's a few second average power draw with it under a thermal load, and it's just a bit over 30 watts. I don't really see any redeeming points for this iron, so this one is a no. Now this MEAKEST brand iron is the one that was bent. Turns out it wasn't hard to fix that. The heating element pins are in sort of a socket, so just straightened it up and threaded the end piece on properly, and now it looks like it should. This is listed as a 90 watt adjustable temperature iron, so it's not temperature controlled. It's doing a good job on the PCB test. I would even say this is the best so far. No complaints about that. Temperature is reading a bit low. Looks like 638 was the maximum I saw. I think that is a good sign considering how good it did on the PCB test. This test was done before I fixed the end of the iron. I really do like this test for showing the heat transfer of an iron. Wow, about 7 seconds to melt the solder. And this iron is not running extremely hot. I'm very interested in what the power draw tests show for this iron. So a bit over 900 milliamps at start. Again, looks like wattage is going to be falling to around the 30 watt range. Okay, this one is pulsing power on and off, so I'll have to use the average mode of the meter. So average power under thermal load is a little over 30 watts. This is only listed as an adjustable temperature iron. But average power with no thermal load is a bit under 25 watts. So even though this is not listed as a temperature controlled iron, it seems to be closer to one than some of the ones listed as temperature controlled. The 30 watts of continuous power under load makes me wonder about my power measurements here. It really did well on the copper strip test. The tip doesn't run hot, heat transfer is great, it feels much more powerful than 30-35 watts. I also like the way this iron feels in my hand. This is my favorite so far, so yes on this one. This is the Q-MING brand SIK 100 iron, listed as 100 watts and adjustable temperature. And it's doing a good job on the PCB test, kind of like the previous iron. This tip may be a bit hotter, but it's doing well. Temperature is right where I would expect it to be for 400 degrees centigrade setting, so it is hotter than the MEAKEST brand iron. I'll get a good blob of solder on the tip and I would expect good things from this iron. Puddle of solder cooling off a bit. This is really unexpected. It's been over 3 minutes. I did notice I bumped the temp up button, so I set it back to 400. That may have interrupted heat for a couple of seconds, but I was expecting 5 to 10 seconds to melt the solder. This is very disappointing. And this is why this test is important. PCB test and temperature did fine. This shows a real weakness in heat transfer. That does look like it says 100 watts. It will probably pull that for an instant when powered up. Bit over 900 milliamps at startup. There's the 100 watts. This iron also pulses the power on and off, so I have the meter reading average. No thermal load and average over about 10 seconds is right around 30 watts. Why am I not surprised? I know I have a good thermal connection. The tip is soldered to the bar. Again, reading average here. And power is going up a bit, even though this iron is not listed as temperature controlled. Though going from 30 watts to 35 watts, maybe 40 watts, not a great temp control system. Better than nothing, I guess. Maybe 40 watts of continuous power is what I'm measuring. Even though it did end up eventually melting the solder on the copper strip, anything over 2 minutes is not good. So this one is a no. This is the KERNOWO brand 100 watt iron. It's listed as temperature controlled, and it's doing a pretty good job on the PCB test. Temperature reading is about where I would expect it to be, so that's good. Solder is staying very liquid under the tip, so this should finish the test. And there we go, about 32 seconds. That's not great. Maybe 750 milliamps at startup. I'll set it to maximum temperature and see what happens. I have the meter in the average reading mode, and with no thermal load, looks like it's close to 25 watts, really what I would expect from a temperature-controlled iron. I'll put the iron to the copper bar and turn on the average mode. Power is increasing, but not by much. A new average sample here, it's like 30 watts or so, probably close to what the continuous power is. I'm going to say no for this one, just not enough heat or heat transfer. This is the HANDSKIT brand. It's listed as 90 watts and temperature controlled. It's doing fine on the PCB test, though the iron is not comfortable to hold, and the tip does seem a bit hot. Temperature is a bit high, set at 750, reading over 800, so probably 100 degrees over temperature. A lot of initial heat. Solder turned very liquid under the tip for a second. Now the solder is more of a thick paste. This is going to take a bit. Over 2 minutes later, and it just started to melt the solder on the end of the strip. Very poor heat transfer, especially for a hot running iron. I think I saw 1.8 amp startup current. Could this supply continuous 90 watts of heat? I'll set it to its maximum of 896 degrees. Now, that may sound impressive, but that's 480 degrees centigrade. Several of the other irons will go to 500 degrees centigrade. Power is dropping as I would expect it to, but still pulling more than most of the other irons I've tested in this batch. I'll let it stabilize and see. This iron pulses the power on and off, so we'll have to use the average mode to measure. 30-second average with no thermal load is a bit over 30 watts. Seems to have a very slow thermal response, but it does seem to be trying to control itself. It looks to have leveled off at about 45 watts. So I would say this is a temperature-controlled soldering iron, though one with a very slow response time. This one might be getting close to 60 watts of continuous power. Poor thermal transfer and a horrible handle put this one way down the list though. Even though it's the only one of the 10 I would say is truly temperature controlled, I'm going to say no to this one. I did want to include this as an example of a 60 watt temperature controlled soldering iron. This is the HANSKIT FX888D, probably known for the worst user interface a soldering station has ever had, but despite that, a very good iron. At power on it only pulls about 200 milliamps, but the heater will kick in a second. Temperature is set at 750 degrees Fahrenheit. It's always set at that, because I would have to look up button presses to change it. It does take a bit to heat up, and I will have to use the average mode as the power is pulsed on and off. No thermal load and it's just under 40 watts. It will drop a bit more if I just let it set there. I've got average mode off here and can see the power is pulsing on and off. It doesn't take but a few seconds for the pulsing to stop, and now the iron is being driven at maximum. Just under 70 watts being pulled by the soldering station, and it's listed at 70 watts on the label. Go figure. The temperature readout on the station has dropped to about 725 degrees. This is of course way too big a thermal load for this iron, but it's doing all it can. Now I know it's not fair to compare a $100 plus soldering station to under $20 irons. The point of this is not to compare irons, but to compare the wattage. It doesn't cost anything to list an iron at its actual wattage. This HANSKIT iron on this station is listed at 65 watts on its label, and it's very close to producing that much heat. I don't think any of these 10 irons produce the heat that their wattage rating implies, so my advice of at least getting a 60 watt iron to replace the joystick module in a game controller is useless and wrong, as you can't go by the wattage listing on the irons, and that is a shame. I guess I need to add a note to the description of that video to ignore that part. I wasn't expecting a lot from any of these soldering irons, but I did expect the power to be closer to what was listed, and that's disappointing. I want to make a very important point here. If you are wanting to learn to solder, starting to mess with electronics, either building or repairing stuff, don't buy any of these irons. These are not good irons to learn with. They will encourage bad habits and create frustrations that are just unnecessary. Get yourself the best soldering station you can afford. It's a very important tool for the workbench. That being said, if all you need to do is solder a small wire back in place, then really any of these irons could do that. Well, maybe not the $7 one. If I was going to buy one of these soldering irons for a one-off job, it would be the MEAKEST brand one. I do think it stood out well above the rest, and not because the end of it came bent. I would hope that was just a rare event, but if not, it is easily fixed. I found it the most comfortable in the hand. Temperature seemed pretty good with it, and heat transfer was the best of the bunch. This one does make me wonder if my power measurements are correct. I would say this iron produces well more than 40 watts. The numbers don't show it though. But I feel the copper strip test is by far the most important and telling test, and it did really well on it. Of course, I only tested one of each iron, and I could have gotten a very good one or a very bad one. These are so cheap I don't really know how much consistency to expect in them. Probably not much. The irons are cheap, the tips are cheap, and I wouldn't say I highly recommend any of them. But in the under $20 category, some of them do produce enough heat to do a decent job of melting solder. Thank you for watching.